Imagine a computer network as a vast, lightless ocean. Somewhere in that darkness are servers, firewalls, and routers. But before you can attack a target or defend one, you have to know it actually exists. You need a sonar pulse. That pulse is Nmap, short for Network Mapper. It works by sending specially crafted packets into the dark and analyzing the unique responses that bounce back. It finds the active devices, checks which doors are unlocked, and reports back on exactly what hardware is sitting in the void. The tool is built around a straightforward syntax. You type Nmap, specify the exact scan options you want to run, and then point it at your target. That target can be a single IP address, a host name, or an entire subnet containing hundreds of potential devices. Going into a network without a comprehensive map guarantees you will miss critical vulnerabilities. You have to chart the layout first. That makes Nmap the absolute starting point for any professional penetration test. The entire process starts with host discovery. When you drop into a new environment, you don't care about specific ports or software yet. You just want to see what is alive by sweeping the broad subnet. You do this using a ping scan, triggered by the -SN flag. This tells Nmap to sweep the network and check for online hosts, while intentionally skipping the port scan phase. It is a highly efficient way to map out all active devices in a fraction of the time. If you are already inside a local network, you run the ARP ping scan with the -PR flag. Because it relies on low-level address resolution protocol requests rather than standard pings, it operates with extreme speed and excels at bypassing traditional firewalls that block standard traffic. By isolating the active targets from the dead IP addresses, you clear the board. Now you can transition your focus from a wide area sweep to highly targeted, granular reconnaissance on specific machines. Once you isolate an active target, the focus narrows. Every single IP address has 65,535 individual ports. You can think of these as potential entry doors, and Nmap is designed to test every single one. To test these doors without tipping off the target, professionals use the TCP-SYN scan, triggered by the -SS flag. This requires root privileges and relies on a half-open connection. The attacker initiates the handshake by sending a SYN packet, and the target replies with a SYN ACK, signaling that the port is open. Here is where the evasion happens. Instead of completing the handshake, the attacker abruptly sends a reset packet, an RST. By abandoning the connection right before it finalizes, the interaction bypasses most application-level logging. The target never registers the visit. If you lack root access, you have to fall back on the TCP connect scan with -ST. This completes the full three-way handshake using the operating system's default network functions. It works reliably, but it is much slower and guarantees your IP address will be recorded in the target's logs. Nmap can also map UDP services like DNS or DHCP using the -SU flag, or deploy evasive packet techniques like the NULL, FIN, and XMAS scans. These send packets with missing or intentionally abnormal flags to easily slip through strictly configured intrusion detection systems. Categorizing these 65,000 doors as open, closed, or filtered gives you the mechanical layout of the machine. This list of open ports becomes your entire exploitable attack surface. Simply knowing a door is open provides insufficient intelligence. The operative must identify the specific software behind it to understand the risk. This is handled by service version detection using -SV. Nmap reveals that port 21 is running VSFTPD version 2.3.4, pinpointing the specific software version behind the door. You combine this with operating system detection using the -O flag. Nmap sends a series of complex probes to the target, analyzes the subtle quirks in how the machine responds, and matches those behaviors against a vast database of known OS fingerprints. Specific, outdated software versions carry known, documented vulnerabilities. By pulling the precise service names and operating system data, Nmap turns raw network statistics into actionable intelligence for your exploits. Nmap has another layer that pushes it past simple reconnaissance. The Nmap Scripting Engine, or NSE, contains over 600 specialized scripts that transition the tool into a platform for automated security testing. Adding the -sc flag runs the default script set. These are generally safe, non-intrusive scripts designed to pull basic information like server titles and configuration settings. It serves as a reliable starting point. But if you run the vulnerability scripts with -script vuln, Nmap becomes much more active. It aggressively probes the open services it just mapped and tests them against a database of severe known security flaws. You can target specific parameters, check for anonymous FTP logins, or expose the Eternal Blue vulnerability. The scripting engine bridges the gap between mapping a layout and identifying vulnerabilities. It analyzes the target architecture and flags the specific misconfigurations or bugs that allow for a successful compromise. Network scanning always requires balancing speed against stealth. Nmap provides timing templates from T0, which is intentionally slow to avoid detection, up to T5. For standard professional engagements on a reliable network, T4, or aggressive timing, is the professional standard. Because these scans generate massive amounts of vital data, you have to document your findings. Using the -OA flag outputs your entire scan simultaneously into standard, XML, and greppable text formats, so you can feed the intelligence directly into other tools. Master penetration testers do not run these individual flags in isolation. They layer them together to execute a single, comprehensive reconnaissance sweep. The ultimate scan command looks like this. You type Nmap. You add -SV for service detection, -C for default scripts, O to pull the operating system, and -T4 for aggressive speed. You add -P for all ports, and -OA to document findings. Executing this string initiates a comprehensive interrogation. Nmap instantly identifies every open port, software version, and operating system detail, checking for security flaws in a single pass. The digital darkness is fully illuminated. You have your tactical map, you know where the weaknesses lie, and are ready for the